All right. So this time we're going to keep up with our definition. So that's awesome. And this time we're going to be looking at observational studies versus designed experiments. All right. These first two examples, I'm going to scoot this up just a little bit, are going to show the difference between the two. Now, I'm not going to read through all of this because you can read and it takes a long time to do that, but we're going to get the gist of it. All right, we're going to skip through this a little bit just so you can see what's happening here. So on this first one, cellular phones and brain tumors. Cellular phones and brain tumors. We're looking at the same thing on both of these. It's just two different ways to approach it. All right. So researchers wanted to determine whether there's an association between mobile phone use and brain tumors. To do so, 791,710 middle-aged women in the UK were followed over a period of 7 years. During this time, there were 1,261 incidences, that was tough, of brain tumors. The researchers compared the women who never used a phone to those who used them and found no significant difference in the incident rate of brain tumors. So what do you think, observational or designed? Yeah, they're just observing. They're just following. Are they making anything happen? Are they setting anything up here? No. This one is observational. Now look at how long this next paragraph is. What do you expect to happen? Yeah, so let's check this out. I bet it is designed. I'm not going to read this whole thing because yikes, right? Researchers from the United States National Toxicology Program conducted a study to address the concern of RFR, so those radio frequency radiation, all right? Certainly, it's unethical to propose exposing humans to this, so rats were used. The researchers randomly assigned 90 rats to 3 groups. Each group was housed in a chamber and rats that allow rats to be exposed to RFR. Group 1, control group. They didn't have any. Group 2 was exposed to a specific time. A specific type of RFR, which was GSM. Group 3 were exposed to a specific type of RFR, which was CDMA. So both of these types of radiations were performed 10 minutes on, 10 minutes off. A total daily exposure of 9 hours a day for 7 days a week for 2 years. Now, do you see what's happening here? How designed is this? Like very specific. Each chamber had 12 light dart cycles. The temperature was regulated. The humidity was regulated. Their air was changed out 10 times per hour. All the rats had the same access to food and water. And then the researchers found low instances whenever they were exposed to the different types of radiation, and no cases in the control group. However, the incident rate was not statistically significant. So both of these are experiments. This first one we determined to be observational. What about this second one? Yeah, totally designed, right? It's laid out, very specific. Control groups laid, it's just controlled, right? I've designed out this very specific 2-year-long experiment that's going to happen. So do you see the difference here? One is very particular, and then, which is your designed, and then observational, you're just seeing what's happening there. Okay, so there's examples of both of these. Now let's talk about these variables. It's very important to have an explanatory variable and a response variable because you're going to have to identify what those are. So in research, we wish to determine how varying the amount of an explanatory variable, which is your input, affects the response variable, which is your output. So the explanatory is what you're doing, right? Is how you're affecting this, is what you're inputting. It's what you're working with in that variable. The response variable is in response to what you're doing with the explanatory. All right, that's your output. You input the explanatory, you're doing something to that, and then the response to what happens with that is your response variable, your output. All right? Okay, so here's our 2 different types of studies. Let's get the definitions down. An observational studies measures the value, the response variable without is the key to this one. without attempting to influence the value of either the response or the explanatory. That is an observational. So what do you do when you observe? You sit back and watch, right? An observational study, the researcher observes the behavior of the individual, just observes without trying to influence it. So I'm not trying to make something happen here. I just am sitting back and seeing how it all plays out. Okay. And then in contrast, a designed experiment is if a researcher assigns, right? So randomly assigns the individuals in a study to a certain group and intentionally manipulates the value of the explanatory variable at fixed values. So intentionally manipulates the value of the explanatory variable and controls other explanatory variables at fixed values. And then records the value of the response variable for each individual. So do you see how this is an input-output situation? Here I'm going to randomly assign individuals of a study to a group, and you intentionally manipulate, so on purpose, the value of the explanatory variable. So I'm giving, a certain amount, just like here, a certain amount of radiation up here in this example. It controls the other variables at fixed values. The same humidity, the same room temperature, the same amount of light and darkness, right? All of those are controlled. And then you record the value of the response, because the response is just the output. I'm doing work to the explanatory variable, the input, the thing I'm working with. The response variable is just what comes out of that. All right? Okay, I want to make sure you get these definitions so you know what's happening there. All right, so then let's look at this example. Do flu shots benefit seniors? Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors age 65 or older by looking at records over 36,000 seniors for 10 years. The seniors were divided into two groups. Group 1 were seniors who chose to get the flu shot. Group 2 were seniors who chose not to. After observing the seniors for 10 years, it was determined that seniors who get the flu shot are 27% less likely to be hospitalized for pneumonia or influenza, and 48% are less likely to die from pneumonia or influenza. Right? Wow, that sounds awesome. All seniors should go out and get a flu shot, right? That's what we're talking about. Here's the deal. Not necessarily, because this is what we were concerned about whenever you're looking through this. There is something called confounding, all right? They were concerned that lower hospitalization and death rates may have been due to something other than the flu shot, because this doesn't say this is only based on the flu shot. You can get pneumonia or influenza from other places, right? So is it really that, or could you get it from somewhere else? We don't know. And that's part of this next aspect of it that you got to really pay attention to. Confounding, is a study occurs when effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response may be due to something else, some other variable or variables not accounted for in the study. And that's part of what happens with observational. You can't account for everything that you're doing. In a designed experiment, you take out some of those confounding variables. But if it's in just an observational, that also makes a difference too. Sometimes in a designed experiment, you don't think about what could be confounding, and then it makes an impact. So that's what confounding does for you. And with our confounding, you can have what's called a lurking variable. So a lurking variable is an explanatory variable that was not considered. in a study, but that affects the value of the response variable. So in addition, lurking variables are typically related to the explanatory variables considered. All right? So here is a confounding variable is an explanatory variable that was considered in a study whose effect cannot be distinguished from a second explanatory. Sometimes there's no way to get around it. You just have to call it out. Here's a confounding variable. There's nothing I can do about this. If you're talking about the weather and you have to be outside on something, you don't have control over that. That is a confounding variable because you don't have control over it and it is not separated, right? There's nothing you can do about it. That's what makes it confounding. All right? Okay, so let's talk about this big difference here between lurking and confounding. So suppose Professor Egner wanted to conduct an experiment in which she compared student success using online homework versus traditional book homework. To do the study, she taught her morning stats class using the online homework and her afternoon using traditional textbook homework. At the end of the semester, she compared the final exam scores for the online section to the textbook. If the morning section had higher scores, could Professor Egner conclude that the online homework is the cause of the higher exam scores? What do you think? Yeah, so here's the deal. Is it possible that the morning class were more motivated? We don't know, right? We don't know. Morning class was more motivated? You have two totally separate groups of students. Sometimes it works that way. Sometimes not. I'm telling you as a teacher, and I've been doing it for years, different classes have different personalities, and it happens. It's impossible to know whether the difference between these two is just motivation, the actual online homework, the group of students. There's too many variables, too many what ifs, right? And that's where that confounding and lurking variables come into play when you're looking at this. The big difference between lurking and confounding variables is that lurking are not considered. That's the key. For example, we do not consider lifestyle in the pneumonia study, whereas confounding variables are measured in the study. For example, we measured morning versus afternoon. All right? So lurking is not considered, not even something that I'm thinking about. Confounding means it's out of my control. All right? Okay, so it's all about the definition, so pay attention to these kinds of words.